9s, we are ready now to learn how to write the formula of compounds using valencies. So that's without the use of Lewis structures. Our first example is a common compound, sodium chloride. So the background knowledge is that I must know that sodium is a group 1 element, so sodium will have a valency of 1 because it's in group 1. The valency is 1. Chlorine is in group 17 and its valency is 1 because the valency of sodium is the same as the valency of chlorine. When we write the formula, we say 1 sodium joins to 1 chlorine. So this is the formula for sodium chloride. Next we go to magnesium fluoride. So magnesium is in group 2 and its valency is 2. And fluorine is in group 17, its valency is 1. So if these are the valencies of the elements, how can I get these valencies to equal each other? I can multiply the fluorine's valency by 2. So the formula for magnesium fluoride, you need 1 magnesium with a valency of 2 and 2 fluorines with each a valency of 1. So together it will have a valency of 2. So this is the formula for magnesium fluoride. Third, we go to aluminium and we join it up to bromine to make aluminium bromide. Now, aluminium is a compound in group 13, so its valency is 3. Bromine is a compound, is an element in, sorry, I'm talking nonsense. Aluminium is an element in group 13, so its valency is 3. Bromine is an element in group 17, so its valency is 1. So to get these valencies to be equal, I need to multiply bromine by 3. So the formula for aluminium bromide, 1 aluminium will need 3 bromines to make aluminium bromide. Our fourth example is sodium oxide. So sodium is an element in group 1, so its valency is 1. Oxygen is an element in group 16, so its valency is 2. How can I make these valencies equal? We multiply the 1 by 2. So that you'll have 2 sodiums with each with a valency of 1 to join to 1 oxygen with its valency of 2. Remember that valency is the number of bonds that the element can form. So the formula for sodium oxide is Na2O. Next we get beryllium oxide. So beryllium is an element in group 2. So I write beryllium's symbol down and below it I write the valency down. Oxygen is in group 16. Its valency is 2. So to write beryllium oxide's formula, it's BeO. So the ratio between beryllium and oxygen atoms will be 1 to 1. Next we had aluminium oxide. This is a challenging one. So aluminium has a valency of 3. So I write Al with a 3 below it. And oxygen is an element with a valency of 2. How can I get 3 and 2 to equal each other? The lowest common multiple for the 3 and the 2 is 6. So to change 3 to 6, I have to multiply by 2. Sorry, 2, not 3. And to change the 2 to 6, I have to multiply by 3. So aluminium oxide is a compound that's got 2 aluminiums in the compound and 3 oxygens. Our next example is aluminium sulfide, and it's very similar to aluminium oxide because the oxygen and the sulfur, they're both elements in group 16. So both those elements will have a valency of 2. So aluminium in group 13 has a valency of 3. Sulfur in group 16 has a valency of 2. To make 3 and 2 equal, I need to multiply the 3 by 2, so there will be 2 aluminiums in the compound, and I need to multiply the 2 of sulfur by 3. So aluminium sulfide has the formula Al2OS3. You can see the pattern that it forms with aluminium oxide. Last one is hydrogen oxide. So hydrogen is a group 1 element, so its valency is 1. Oxygen is a group 16 element, so its valency is 2. It can form 2 bonds. So to equal these numbers, I need to multiply the hydrogen by 2. And some of you might see that this is the formula for water. So now you know another name for water. It's called hydrogen oxide. Lastly, I want to teach you about stock notation. Stock notation involves mostly the transition elements, valencies. Because these elements can have more than one valency, we need to indicate the valency with the brackets and the Roman capital I, or 1, after the metals symbol. So the first one we do is silver chloride, and the brackets 1 tells you that silver's valency is 1. Chlorine is in group 17, so its valency is 1. So silver chloride's formula is AgCl. Next we have iron 3 oxide. Now iron 3 means that iron has a valency of 3 and oxygen is in group C16, so its valency is 2. So this looks similar to the aluminium oxide situation. So we need to equal these numbers. So I multiply the 3 by 2 and the 2 I multiply by 3 to get them equal to 6. So iron 3 oxide is Fe2O3. Next we get copper 2 chloride. So copper 2 means copper's valency is 2 and chlorine in group 17's valency is 1. So to get these valencies equal, I need to multiply the 1 by 2. So copper 2 chloride is CuCl2. Last one for this video presentation is cobalt 3 chloride. So cobalt 3 means cobalt's valency is 3. Chlorine, I know by now its valency is 1. So I need to multiply the 1 by 3 to get it equal to 3. So cobalt chloride's formula is CoCl3. I hope you enjoyed the presentation. More examples on using stock notation that I left out initially. So let's go. For example 5 is iron 3 chloride, meaning that the valency of iron is 3, so I write the symbol of iron and a 3 below it. Chlorine is in group 17, so its valency is 1. To make these valencies, these bonding possibilities equal, we need to multiply the chlorine by 3. So the formula for iron 3 chloride is FeCl3. Number 6 is copper 2 oxide. So copper's valency is 2, indicated by that in brackets. And oxygen is in group 16, its valency is 2. So these valencies are equal. So copper 2 oxide's formula is CuO. Copper 1 oxide, number 7, the copper's valency is 1, where oxygen's valency is 2. So we need to multiply the valency of the copper by 2. So the formula for copper 1 oxide is Cu2O. 2 coppers joined up with 1 oxygen. Lastly, we have iron 2 sulfide. So the valency of the iron is 2, and sulfur in group 16's valency is 2. So iron 2 sulfide has the formula FeS. I hope you found this very useful. Thank you for watching.